Namaste. This is JV and Dr. Vishal Saxena, Professor in Mathematics in Faculty of Education and Methodology, JAYOTI VIDYAPEETH Women's University, Jaipur. So today I am going to discuss on the module Homogeneous Differential Equations and its solutions. And this module is a part of the course Business Mathematics under the program of BBA and BBA LLB second semester. So the today's lecture is about the homogeneous differential equations and the method by which we can solve a homogeneous differential equation. So in the last lecture we have discussed about the differential equations and its order, degree, and the one of the method, basic method of the solution for the differential equation, that is called variable separable form, variable separable method. In the today's lecture, homogeneous differential equation, first we have to understand what is meaning of a homogeneous function. For a homogeneous function, that means it is a kind of function where the function means every term should have the equal exponent form or the equal integral power. Then it is called homogeneous function. So we can see there, suppose I'm taking one example, like x square plus y square and plus z square. So this is called a homogeneous function, x square plus y square plus z square. So first we have to understand what is why this is the homogeneous function, because there are three terms, x square, y square, and z square, and these are in addition or subtraction. So ultimately, if all the three terms are just homogeneous, then it means if these three terms are with same degree, then such function is called homogeneous. I am taking some more examples to explain this here. Suppose I am taking here like x plus y whole square. Then if I will take here x plus y whole square plus x minus y whole square. So again, this is a kind of the homogeneous function, because we can see if we open this whole square, then again we will have the every term of degree 2 term. So that's why it is called the homogeneous function, and that is the differential equations about which the homogeneous function is to be taken. So now what is a kind of homogeneous differential equation? So homogeneous differential equation means it is an equation in which the two sides are having the same degree terms. So like suppose I'm taking one example here, first example, dy by dx is equal to x square minus y square upon x square plus y square plus xy. So look at this one here, this left hand side is a 0 degree term there, because d is the notation for the derivative operator. So y by x is the term, and its overall degree, then it becomes 1 minus 1 is 0. In the right hand side term, it is x square minus y square is a homogeneous term, and uh, then it is denominator is x square plus y square plus xy is again a homogeneous term. So therefore this differential equation means the right hand side is a homogeneous function with degree 0, and therefore this differential equation is called the homogeneous differential equation. And in the same, in the one more example, you can see this one, dy by dx equal to x minus 5y upon 5x plus 5. So again, we can see there the differential equation and the two sides, dy by dx is a homogeneous function, and the right hand side is again a homogeneous function. So such kind of differential equation is called a homogeneous differential equation. And now we discuss about how to solve this one. And in a general way, a differential equation of the form fx by dy is equal to gx by dx is called the homogeneous differential equation if the degree of two functions f and g uh, must be same. So the differential equations general form we can give here like as fxy dy and this equals to gxy dx and the two functions f and g if are having the same degree, then such type of equation is called homogeneous differential equation. Now, how to solve a differential equation that is homogeneous? So we first take its a method, what is the procedure by which we can solve a differential homogeneous differential equation. So first we take some steps to explain this. First of all, we have to confirm that our given differential equation is homogeneous, whether homogeneous or not. If it is homogeneous differential equation, then we have to apply its method for the solution. And the first step for the solution method, we have to write y is equal to vx in our given differential equation. Means we have to replace our variable y with vx in our given differential equation, and then we have to differentiate this term y equal to vx. So we have to find dy by dx in terms of v and x. So finally, in the given differential equation, we have to replace our y and dy by dx terms by the terms of v and x and their derivatives. So that is the first step. Now second step is differentiating. We get in this way, and we have to replace this one. Then we just replace our the term of y, that means it is the dependent variable, our unknown function, and it's a derivative. Then we have to put we have to replace in our equation, and then after simplifying the given equation, then it would become certainly, definitely in the form of the variable separable. So the given equation then reduces to the variable separable form, and then just by applying the method of variable separable form, we will get its solution, its general solution, and then in the given solution, then the solution which is obtained here, just again we have to replace our term v by y upon x, and then we will get its a solution. So again, I'm taking in summary. First, we have to put y equal to vx. Then we have to find its derivative term dy by dx. And then we have to put y and dy by dx in our given equation. And means ultimately we have to replace our y. We have to eliminate our y term and the dy by dx term. And then the equation will become in the form of variable separable. And then by its usual method, the reduced equation can be solved. So that is the method by which we can solve any homogeneous differential equation. And now we take one example to clear this, just how to solve a homogeneous differential equation. So look at this one here. What equation is given that? So we are given that an equation dy by dx is equal to x minus y upon x plus y. So dy by dx equal to x minus y upon x plus y, and we can observe that this equation is surely a homogeneous differential equation, because I have explained already that it is a homogeneous differential equation, because in the right hand side term there is a homogeneous function in the numerator as well as in the denominator. So ultimately, it's a right hand side term is a homogeneous function with degree 0, and in the same way the left hand side term is again a homogeneous function with degree 0. So in this way, this is a homogeneous equation, and now we have to put just we have to put here y is equal to vx in this equation. Why? One thing you can do also means just to explain more here whether this is homogeneous or not. That the right hand side term is divided by x. If we divide it by x in numerator and denominator, then ultimately the term reduces to y 1 minus y by x by 1 plus y upon x. So dy by dx equal to 1 minus y upon x and upon 1 plus y upon x. This is again a term showing that this equation is a homogeneous differential equation. Now we apply its a method, general procedure to solve this equation. First, we have to put y is equal to vx. So y is equal to vx means here y is replaced by vx and we have to find dy by dx. Dy by dx will become v. First, how to differentiate this one? By the chain rule. V is as it is here and into derivative of x, a second function which is 1. So ultimately dy by dx is equal to only v plus second function x and the derivative of first function v, that is dy by dx. So that is the derivative obtained by the chain rule. Then here now just what is required to get this is here v plus x into dv upon dx and so now just put this term y and dy by dx in the given equation and then given equation will becomes the given equation reduces to look at here this term on the left hand side term is dy by dx so it will becomes here v plus x into dy by dx, v plus x into dv by dx. And in the right hand side term, just because we have taken like y upon 1 minus y upon x upon 1 plus y by x, and what is y by x? That is equal to v. We can see this one as from this term, it is v is equal to y by x. So finally, in the given equation, we will get v plus x into dv by dx is equal to 1 minus v upon 1 plus v and therefore now just simplify the equation and simplify means just we have to separate our dv by dx term. So dv by dx we have to separate this term and finally you will see this one. First bring this term of v in the right hand side term, take LCM and then just simplify it. So what is obtained there? X into dv by dx is equal to the right hand side term like 1 minus 2v minus v square upon 1 plus v. So that is the term in the right hand side term and the left hand side term is x into dv by dx. Now we have to see whether this equation can be written in the variable separable form or not. So look at this equation and just bring this term of v in the left hand side. So 1 plus v divide 1 plus v upon 1 minus 2v minus v square into dv and is equal to 1 by x into dx. So just we can see there, we can observe that this equation is now in the variable separable form and now the our objective is to solve this equation variable separable form. And just a variable separable equation can be solved by integrating this equation directly. So integrating both the sides, so it is integration of 1 plus v upon 1 minus 2v minus v square dv is equal to integration 1 by x dx and then just integrating this term left hand side. So now it is depending upon integration term how can we like how just we are perfect in integration. So this term can be integrated by the method of substitution. So look at here, if we put the denominator 1 minus 2v minus v square as a term z, then in the numerator term like 1 plus v into dv will be obtained there and in this way this function this left hand side can be integrated very easily. So just put here the denominator term as z. I have done this integration directly because it is not so difficult to do there. So just its integral will be, if you take the denominator as z, then we will get here like minus 2 into 1 plus v into dv is equal to dz. So minus 2 will come in uh, denominator of the right hand side. Therefore, 1 plus v dv becomes like dz upon minus 2z, and in this way we can integrate this one. So finally, what is coming there? This will give us minus 1 upon 2 log 1 minus 2v minus v square, and this equal to log x plus c. So this is log x plus c. What is c is showing here? C is always taken, is always added in the side of the independent variable in a indefinite integral. When you are doing the indefinite integral, then a constant of integration must be added in the side in the which side here, in the side of independent variable. And further, this equation can be simplified more by taking c is equal to log k, because all that, if all the terms being will be in the log, then it can be reduced to more better form, and then you can see minus 1 upon 2 log 1 minus 2b minus v square is equal to log x plus log k, and which will be just simplified by the property of log, like what is log a plus log b, that is log ab, and ultimately this term becomes in this way: 1 minus 2v minus v square whole raised to the power 1 minus 1 by 2 kx, and now just we can simplify more this term by taking this square, and finally just it is coming there. And then at the last, what we have to do, we have to replace our this assumption, v is replaced by y by x, and then we have to simplify it. V is replaced by y upon x, and then we will get its solution as y is equal to plus minus root over 2x square plus c and minus x. So y is equal to just plus minus 2x square plus c root over minus x, and that is the solution for this differential equation. It is the general solution for the given homogeneous differential equation. So that is the way by which a homogeneous differential equation can be solved. And we have discussed today the homogeneous differential equation of first order. But the high order homogeneous differential equations can be solved by a different approach, but that is not in your syllabus. So just this is the homogeneous differential equation of first order, and this is the method to solve the differential equation. So students are advised to make practice more and more questions for just getting command over the solution methods and the solution way for such kind of equations. And with this, I'm concluding my today's lecture. Thank you.